In this lecture, we will talk about the eigenvalues and eigenvectors. Previously, we have seen that the eigenvalue concept and eigenvector concept arises when you assume that there is a solution Q. Remember that we are talking about the solution of coupled PDEs, which are actually acoustic equation. So I will not write the equation again. And after putting the solution into the PDEs, we get a relation between a matrix A and the speed C. This matrix A becomes actually a coefficient matrix, and S becomes eigenvalues. These become eigenvalues, and Q dash becomes eigenvector. So suppose that the fluid is at static position, it is not moving, so it has velocity equal to 0. In that case, the coefficient matrix that I introduced in the earlier video, actually we derived it from the Jacobian matrix. We get A which with components k naught and 1 over rho naught. K naught is the bulk modulus. How to find the eigenvalues of that and why we are interested, you will find out in future videos. So first, from the linear algebra, from LA linear algebra, we know that we can find eigenvalues by using this equation, and at the end we get lambdas. K naught over rho naught is the definition of speed of sound, and since it is at fixed state, so we call it C naught. So it means that we have two eigenvalues. One is C naught and another one is minus C naught. So these are the two eigenvalues. Now, if we talk about the state or the state of the fluid where the fluid is not at static position, but it is moving as well. Remember that over complete analysis, our complete analysis is based on the gases. That's why we are using some relations which are valid only for the gases. For example, P is equal to K hat and something like that, rho gamma. This is only valid for gases. Let me come back to the coefficient matrix again. So if we have, for example, U naught is not equal to 0, then the coefficient matrix, which is written as like this, then we have eigenvalue problem, and from this eigenvalue we can find out the eigenvalues like this. And remember that the previously we had only two eigenvalues which were actually speed of sound moving in different direction. One speed of sound is moving towards right, another one is on the left. And same is the case with when we have u naught is not equal to 0, the speed of sound by theory, by mathematics, it has two directions. One is u naught minus c and another one is u naught plus c naught, right? Maybe not two direction, it depends on the u naught and other things. We will talk about that in future. But here we have two eigenvalues. The only addition in this equation is u naught. So u naught minus c naught and u naught plus c naught. Now the next question is how to find the eigenvector. How to find the eigenvector. So we have entered into the field of linear algebra. So you can see that in finite volume method or any other method, finite difference method, you must have knowledge of uh, linear algebra, numerical analysis, CFT. You need to know about the PDEs, you need to know about ODEs, and so on. So this whole area is combined together, makes a CFT, makes a CFT. Okay. So we reached at finding the eigenvectors, and we already know the coefficient matrix, and after subtracting these two values we get a minus lambda I. This is a minus lambda I, and we put a minus lambda I. Remember that the v over here is the pressure and velocity u. So we need to solve this problem. This problem can be solved by multiplying these together. Maybe, for example, if I just give you the sense how you can find the eigenvectors, you can probably have to go back and learn linear algebra, or maybe revise it, I guess. P C naught plus K naught U is equal to 0, and then we have 1 over rho naught P plus C naught U is equal to 0. And from here, what we do, we actually solve these two equations. So, for example, if I multiply the second equation with rho naught, I get plus rho naught C naught U is equal to 0. And then I multiply this with C naught again. So I multiply this with C naught P plus rho naught C naught square U is equal to 0. And then I solve these two equations together. It means I just subtract it. So I get K naught U minus rho naught C naught square U is equal to 0. When I common U from here, I get rho naught C naught square U is equal to 0. And from here, U cannot be equal to 0. This is our assumption. So we get K naught rho naught C naught square is equal to 0. So it means that we have some quantity over here, K naught rho naught C naught square, and C naught is K naught over rho naught, which is actually speed of sound. So we do not get anything new. If I, for example, write this E C naught K naught U, and then I write P is equal to minus K naught over C naught U. So what you get? For example, the eigenvectors are P and U. You can write this as minus K naught over C naught U, and this is U. You know that from linear algebra U can be taken out, minus K naught over C naught 1, and you just solve it, and at the end you get rho naught C naught somewhere by using some analogy, or maybe some not analogy but by some equation. You can do that. Okay. So that's why we have, or maybe if I did something wrong, you can just correct it yourself. But the idea is the same. That's how you find the eigenvectors. Thank you for watching.